Hi guys, we're starting the quadratic unit now, and there's three forms for the quadratic equations that I want to talk about. The first one is called vertex form, and this is the form we're familiar with. We've been working with that for all our power functions. And the second form is called standard form. I'm sure you've seen this one before. And the third one is factored form. So just very quickly, I know you know how to do this, but I just want to talk about this in a slightly different way. On the left, I have a table of values for our parent function, and notice that from the vertex, I can go over 1 up 1, and over 2 from the vertex up 4, and from the vertex over 3 up 9. We're going to use this to help us write an equation for this quadratic. And again, on the left is the table values for the parent function, and this time from the vertex, when I move over, I go up a fraction of the amount. I'm not exactly sure what. It looks like a half. If I go over 2, I'm only going up 2. So notice on the left-hand side, instead of going up 4, I only went up 2. So the a value here is going to be 1/2. I'm compressing the quadratic. The a value is going to be 1/2 of what it should be. Notice this is a y value transformation. The next one, again, I'm sure you figured out just by looking at it really quickly that the a value is 2, but let's take a look at the steps. So from the vertex, I can go over 1 up 2 now, and go over 2 up, hopefully 8, and that doubles the y values. So this is going to be y equals 2x squared. All right, now I'm going to ask you to write an equation for this function right here. And we can see it's a quadratic. It's been shifted to the to the right 2 and down 3. So because I see the vertex, I'm going to use vertex form for this. It's going to be y equals a, x minus 2 because it shifted to the right 2, squared minus 3. And now we just have to figure out the a value. Sometimes when you have the vertex, it's easy to do this step where you just show over and up. So for this case, I'm going over 2 up 4, and notice from the parent function it's been compressed by 2. So the equation is y equals 1/2 x minus 2 squared minus 3. What if I don't know exactly what the vertex is? Then we're going to have to use a different form. And because I know the roots, I'm going to put it into factored form. Notice inside the parentheses, x plus 4 represents the root -4, and x minus 3 represents the root 3. Remember, inside the parentheses, it's always opposite of what you would think. Now, we still need to find the a value, and in order to do that, we need one additional point. So I labeled a point for you, -5 and -2. I'm going to plug in -5 for all my x values and -2 for all my y values. And now I'm going to simplify inside the parentheses. And please make sure you keep parentheses around these numbers. You can do this any way you want. I'm going to go ahead and divide both sides by -1 and then divide both sides by 2. And do you see why it's important to keep the parentheses around the -4? You don't want to add 4. You want to divide by -4. And so the a value is -1/4. And that does make sense. It's flipped and it looks like it's compressed. Make sure you write the equation out. Y equals -1/4, x plus 4, and x minus 3. And the last thing I want to show you just very briefly is I have this equation, y equals x squared minus 4x minus 5. And I factored it also. So do you see the difference between the green and the orange striped ones? These are the same equation, and it has an axis of symmetry of x equals 2. That's also the x value of the vertex. I just want to show you something interesting. If I change the a value in the factored form to like 1/5, it's compressing the equation, but notice what's the same. The roots are the same. The root is -1 and +5. That stays the same. The other thing that stays the same is the x value of the vertex, or the line of symmetry. That would work also if I stretch the equation. For example, this one here is 2. The roots are still the same. The axis of symmetry is the same. I can also flip it, make it -1. and the roots will stay the same. This only works when you change the a value in factored form. All right, do the rest of your work now. Bye.